Hi ROS developers. On a previous video that we released some weeks ago, it's a ROS question and answer 104, we showed how to modify a URDF of a Turtlebot in order to add a join here. And then at that point in time, we saw how complex it was to launch this full simulation because it contains a lot of launch files, one that calls another, and then it includes some files in parameters, etc. So it was quite a complex launch situation. So today here we are going to see how we can analyze this complex situation of a launch file that contains many launch files and config files, etc. by using a tool that is called the RQT GUI with a special plugin. Okay, so that is what we are going to analyze today. And for that, we are going to use, of course, as always, the ROS Development Studio that you can access at any time for free at rds.theconstructsim.com. You can just go there and do the same things I'm doing here, like launching the Turtlebot simulation and downloading, compiling everything. In any case, if you don't want to do the steps on the ROS Development Studio, you can do the same things in your local computer. Just have to have the proper simulations and data available there. Okay, anyway, so let's start. So first of all, I want to see here that I have already launched the Turtlebot simulation here. You can see it's let me put it a little bit bigger. So here it is, that this is the simulation that I have installed into this simulation workspace. Okay, and here it's the Kabuki simulation and the launch file that we are launching. You can see that there are many launch files, many packages. And the one that we are launching is the one that is here. Let me see, on inside the Turtlebot gazebo main launch. So that's the one that I have launched. Okay. So now I want to see what is the sequence of different files that this launch is launching. So I'm going to open, and as you can see here, there are a lot of files and parameters. So I'm including here another launch file that I don't know what it's doing. I'm including here another launch file. I'm finally here launching a node, but with some modifications. So let's see how we can see this in a graphical way so we can understand what is the concatenation of all those launch files. For that, we are going to use the RQT GUI with a special plugin that is called RQT Launch Tree. Okay, you can find it here. I will put a link beneath the video for accessing this. And here is basically what we are going to get. So let's go to that point. So in order to get that, this is not a pre-installed plugin. So maybe you will have to install it either by doing this, just an apt-get install in your local computer, but in the RDS, we are going to install from source. So it's very simple, so you'll see. Then for that, we need a shell. Let's open a shell here. Let me put it here so we can have some space. Yeah. So yeah, like this. And then we need to go to the Catkin workspace because, as you know, in RDS, we have several workspaces. One is the simulation for your own simulations. That's the one that I have here for the Turtlebot. Another one is for the notebooks, when you include notebooks for creating explanations for your students or for yourself. And the other one is the Catkin workspace that contains your ROS code, basically here in the source. In this case, I have some laser tools that you can look at this in previous videos that I have done. So anyway, we have to put it here in the source. Let's go for it. So for that, let's go to the Catkin workspace and the source. And here, let's do as this page indicates. Let's do the git clone. So let's get it, copy, and here paste. Let's clone it. And okay, we got it. Now let's compile it. And as you probably know, you have to go one directory down and then do a catkin make. And then this package will start. compiling. So we have it there, it's compiling, and once we have it, we are going to use the RQT GUI application to load this plugin. And once the plugin is loaded, then we'll be able to decide which launch file we want to analyze. And as you will see, it's very simple. It's quite easy. Okay, so it has already compiled everything. So here you can see that it's already compiled because I was preparing previously, so I had already compiled. And then so let's go. The only thing that we need to do is to launch the RQT application, and here it specifies something. In order to launch it, it says that we may need to pass this force discover for the first time in order to add this additional plugin that we have just integrated. So let's use this option also. Okay, so how do we launch the RQT? Very easy. ROS run RQT GUI, and then the option force. It was force. What was discover? Okay, force discover. Okay, so now we launch it. Okay, so there it is, launch it. So where it is, this application? So if you know, RQT is a graphical interface. So here, in order to appear here on the web, we have to open a special window for that. This is included in the tools, graphical tools. So if I open this, a new window will show, that is this one. And here we have the RQT GUI loaded. And already, okay, so I'm going to close this because you should have it like this, like an empty RQT GUI. So let me also make it bigger so we can get most of the space as much as possible, as big as possible. And here beneath. Okay, great. So you have this, and now let's go for the plugin. Then you have to go to the plugins and then configuration here. So once you click on the configuration, you have to select the Launch Tree. This is the plugin that we have selected, that we have installed. So select this one. As you can see, is the Launch Tree here on the tabs, is the one that we have launched. Okay, and then okay, so in this case you have to select the launch file that you want to analyze. In our case, as I indicated previously, we want to analyze the launch file that we are using to launch this simulation of Kabuki. So let's go here and let's see where it is. Let me show you. It's inside the Turtlebot gazebo main.launch. Okay, so you go here, press in the launch files here, select the package. In my case, it's Turtlebot gazebo. I have found it. You have all the packages that you have installed in the system. Okay, so it may take you a while to reach yours. So that's it. I have selected the Turtlebot, and then here you can select the different launch files that are included into that package. Main.launch, selected. Okay, let's refresh it, and we got here the whole structure that this launch file is using for launch the whole simulation here. And what do we have here? Okay, so let's go step by step, and I'm going to put it here on the side so we can see. We don't need to see the simulation, but we may need to see here the code so we can understand better how it works. Okay, so the next time you don't need to watch the code, the actual code, but just looking here you will understand everything. So what do we find here? Okay, so after this launch file, what it does is, first, it contains other launch files. So this icon here represents other launch files, and if you press on any of them, you will see that it contains the package that is containing the launch file, and then the launch file that we are launching inside that package. Okay, and that makes perfect sense. If we come here to the main.launch, you can see that we have an include. Then include, every time that we got the tag include, we got the another launch file that has to be launched. So we have include here for empty wall, that is the one that we can see here, and another one for Turtlebot gazebo, that is the one that we have here with an argument on launch XML. And if we come here, we can see Turtlebot gazebo, that is Kabuki. So it has been resolved correctly, this value. As you can see here, it contains a value, so for the launch file. But the plugin correctly achieves to resolve. Okay, so you can see here, okay, that main launch file is launching two other ones. Then what else is doing? Oh, it's starting a node. Is this node here that is called Robot State Publisher. So this means that the launch file is launching that node here. So if we come here again, we can see here the node that is being launched. Let me increase a little bit the size of the fonts so you can see better. Great. So here is the node. Okay, the name here is the one that is shown here. Then it specifies from which package and which executable and other parameters. As you know, from a node, if you go to the documentation of the ROS launch, you can see here, XML node, you can specify several attributes like the name, what is the name? Sorry, no, it's not that, sorry. It's, oh, yes, no, yeah, it's that. So that is the package. Yeah, it's here. Sorry. Okay, here is the package, the type, that is the executable, and then the name that you assign to this node. Okay, so and many others. In this case, we have the package, the type, the namespace, and then arguments, some extras. Great. So you can see here that the node is being launched, and something inside will go there at any point in time. So now, what else do we have in this launch file? So, okay, so what we have are arguments. So those arguments are, you must not confuse with parameters, okay? Those are arguments, and the arguments are values that you can provide to the launch file in some way, okay? In this case, we have an argument that is called 3D sensor, which value is Asus Extium Pro. So if we come here, we go at some point here, 3D sensor, value Asus Extium Pro. Okay, so that's it. And we have many others, base, debug, for example. Debug, instead of having a value, it has a default value of false. And you can see here that debug is here. It has a tag default instead of 3D sensor that has a value. That is not default, but value. What does it mean? It means that this argument cannot be changed when launching the file. When you do the ROS launch, you cannot provide to this launch file a different value for 3D sensor. This is like fixed. Instead, for debug, you can provide a different value. If you do not provide a different value, then false will be taken. But during launch file, during the launch time, you can say ROS launch, Turtlebot gazebo, main launch, and then specify for the debug parameter, argument, provide the value of true, for example. So that's a difference. And you can see here any difference and many other arguments, okay? So that's up to here. You can check here in the documentation of ROS launch many other information about the arguments and what it's the meaning of default, of value, etc., and have a wider understanding. Great. So what else? So inside here, the node, do you remember we are launching the node? Then here inside we have more things. What do we have? Okay, so first we have a parameter. This is something different, okay? So this is not an argument, but a parameter. And what does it mean? A parameter, what is the difference? So you can check here in the documentation of parameters instead of arguments, okay? So arguments are things that are passed. are provided to the launch file during launch time, usually. And parameters instead, it's values that are stored at some point in the param server of ROS and that you can interact with during your launch file. So in this case, for the robot state publisher node that we have here, robot state publisher, we are providing this parameter to the param server. So we get this with this value. So we know that when this node is launched, this parameter, publish frequency, will be set to 30. And why do we do that? Well, because probably the robot state publisher is using this parameter. And we want it to be set to this value for the execution of this. Great. What else do we have? Then you pay attention to the different icons, okay? So you can identify. When you have some experience, you will do this very quickly. So then another thing that we have is this value, this icon here, strange, that is called joint states. And what is that? That is a remap. What's a remap? If you remember from launch files, means that you can remap topics from one thing that your program is expecting. So this program, Robot State Publisher, is expecting that somebody is providing the joint states on a topic that is called joint states. That's what this program is expecting in order to run properly. This node of ROS is expecting that. But in this simulation, for whatever the reason, nobody is publishing in this topic, but instead the same information for that is published in another topic that is called different. So simple model to joint states. Okay, no problem. We can do this remap. So we remap from what is expecting the program to what is actually being published. That's a remap. And you indicate inside the node tags. Okay, so that's what this icon here is showing. So you get the joint states, remap from joint states to simple model joint states. That's it. So now let's have quickly another look here to the other ones, but you will see that it's exactly the same. So it's this launch file is the one that we have here, gazebo, include the gazebo ROS empty wall. Okay, so here, gazebo ROS launch empty wall. And then we have the same. If we were to that file, we'll find that there is a node that is launched called gazebo that is launching the GZ server. Then the gazebo GUI that is launching the GZ client. And then we have, again, a parameter with some values and many, many arguments. And the same thing we can see here in the Turtlebot gazebo. Okay, so this is for the whole thing. Then in this Turtlebot gazebo, we have a special thing, an additional special thing that you can see that is launching some nodes with their parameters and remaps, some other nodes that no remaps, no parameters, just as they are. But here we have another thing, another icon, a different icon, that this is specifying the load of a config file. So this icon is indicating, hey, please load a config file that is included into the Kabuki description package inside this directory. And what is the content of this config file? Well, a set of parameters. A set of parameters. So we can go to this Kabuki description. Let's go here. Kabuki description is here. And config, and then open the config yam, and we see here the structure of all the parameters. Okay, so maybe this is a little bit confusing because this file could contain a lot, but then here, by watching it here, it's a lot easier. And also you can see the values that have been assigned to each one of those parameters by looking here. Okay, so basically that's it. There is nothing more about this. And so what I will suggest you is that you start using this plugin on RQT and start practicing. So with a little practice, you will be able to watch the structure of complex launch files very easily just by looking here. And then you can get a better idea about how to modify the system. So where do you have to go? If I want to modify the simulation for, if I want to modify the simulation, for example, for finding where to put the joint to the Kinect, where should I go the fastest? Then okay, so I don't know. I will do like this and say, okay, Kabuki description, here it looks like. So I will look for here. So you get a better idea. You don't go blind to start looking through all the files that you have there. Okay, so I hope that this was useful for you. And we are going to stop here today. And remember that we are publishing a new video every day. So if you like these kind of videos, please subscribe to our channel and press the bell so you will be notified of this. Thank you very much and see you on the next video. Cheers!